Hello, welcome all, my dear students. Today we are going to discuss Kepler's law of planetary motion. Coming to the first slide, നമുക്കറിയാം ന്യൂട്ടൺസ് ലോസ് ഓഫ് മോഷൻ ആണ് മെക്കാനിക്സിന്റെ വളരെ അടിസ്ഥാനവും പ്രധാനമായ ഇക്വേഷൻസ്. അത് കണ്ടുപിടിക്കാനുള്ള പ്രചോദനമായി തീർന്നത് കെപ്ലേഴ്സ് ലോ ഓഫ് പ്ലാനറ്ററി മോഷൻസ് ആയിരുന്നു. അത് യഥാർത്ഥത്തിൽ കണ്ടുപിടിച്ചത് കെപ്ലറും അതുപോലെ തന്നെ കെപ്ലർ യഥാർത്ഥത്തിൽ ഒരു അസിസ്റ്റന്റ് ആയിരുന്നു ഓഫ് ടൈക്കോ ബ്രാഹെ എന്ന് പറയുന്ന ഡച്ച് അസ്ട്രോണമർ ആയിരുന്ന ടൈക്കോ ബ്രാഹയുടെ അസിസ്റ്റന്റ് ആയിരുന്നു ജോഹനാസ് കെപ്ലർ. ഇവർ രണ്ടുപേർക്കും വളരെയധികം കഴിവുണ്ടായിരുന്നു. അതെങ്ങനെയാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ബ്രാഹെ യഥാർത്ഥമാണ് ഒരുപാട് അസ്ട്രോണമിക്കൽ മെഷർമെന്റ്സ് പ്ലാനറ്റ്സിനെ നിരീക്ഷിക്കുന്ന വളരെ അധികം കഴിവുള്ള ഒരാളായിരുന്നു ടൈക്കോ ബ്രാഹെ. അപ്പോൾ അവർ രണ്ടുപേരും കൂടെ ചേർന്ന് കെപ്ലറിന് വളരെയധികം മാത്തമാറ്റിക്സിൽ വളരെയധികം കഴിവുള്ള ഒരാളായിരുന്നു. ആൻഡ് ദേ ടുഗദർ ഹാവ് ദ എബിലിറ്റി ടു understand the motion of the planets and design a law to generalize the motion of the planets. അങ്ങനെ ഒരു 18 വർഷം, it took 18 years of laborious calculation for Kepler and ബ്രാഹയുടെ ഒബ്സർവേഷൻ്റെ ഡാറ്റ യഥാർത്ഥത്തിൽ ഫിറ്റ് ചെയ്യാനായിട്ട് കെപ്ലറിന് 18 വർഷം വേണ്ടി വന്നു. And finally he come out with Kepler's laws of motion, planetary motion, and that led to the discovery of Newton's laws of motion, which is the foundation of mechanics. And that three statements or postulates are three Kepler's law. Kepler's first law states that each planet moves in an ellipse with a sun at 1/4c. That means whatever the planets we have, like Earth is one of the planet, and all these planets move in an elliptical orbit where the sun is at the one of the foci, because ellipse has got two foci, like circle has a center, ellipse has got two centers. I mean, it is not center, it is a foci. So this is what it says. So the ellipse has got two foci, and the radius vector from the sun to a planet sweeps out equal areas in equal times. So we can see that the radius vector of the planet from the sun, so that makes a small area as the planet moves. So the radius vector from the sun to the planet sweeps out equal areas in equal intervals of time. That means the rate of area is constant, or that means the aerial velocity is constant. So the third law says that the period of revolution of a planet about the sun is related to the major axis of that ellipse of that planet by the relation t square is equal to ka square. അതായത് ഒരു പ്ലാനറ്റ് സൂര്യനെ ചുറ്റും കറങ്ങുന്ന പ്ലാനറ്റിന്റെ ടൈം പീരിയഡ്, ഒരു പ്രാവശ്യം കറങ്ങാനുള്ള റെവല്യൂഷൻ പീരിയഡ് ഈസ് എന്ന് പറയുന്നത് ആ പ്ലാനറ്റിന്റെ എലിപ്റ്റിക്കൽ ഓർബിറ്റിന്റെ മേജർ ആക്സിസുമായിട്ട് ബന്ധപ്പെട്ടിരിക്കുന്നു. മേജർ ആക്സിസ് ഇസ് ഗിവൺ ബൈ ക്യാപിറ്റൽ A, and the t square is proportional to ka square, and the k is same for all the planets. So the Kepler's first law follows from the results of the last section, and elliptical orbits are characteristic of the inverse square law of motion. ഇത് നമ്മൾ കഴിഞ്ഞ വീഡിയോകളിൽ നമ്മൾ കണ്ടിട്ടുണ്ട്. എല്ലാ ഇൻവേഴ്സ് സ്ക്വയർ ലാ ഫോഴ്സ് അതുപോലെ സെൻട്രൽ ഫോഴ്സ് ലാ ഉപയോഗിക്കുന്ന ഗ്രഹങ്ങൾ അല്ലെങ്കിൽ വസ്തുക്കൾ എലിപ്റ്റിക്കൽ ഓർബിറ്റ് ഉണ്ടായിരിക്കും. അത് നമ്മൾ എനർജി ബൗണ്ടഡ് ആണെങ്കിൽ എലിപ്റ്റിക്കൽ ഓർബിറ്റ് ആണെന്നുള്ളത് നമ്മൾ കണ്ടു കഴിഞ്ഞു, ലാസ്റ്റ് വീഡിയോയിൽ കണ്ടു കഴിഞ്ഞു. ആൻഡ് ഇൻ ദിസ് സെക്കൻഡ് law basically is a general feature of central force motion, and the second law is also a feature of central force motion. And for example, we have already proved in the previous videos. Today we will see once again. We know that the angular momentum, it is given by moment of linear momentum. That is, in this case of the orbital motion of a planet or a body, the angular momentum is given by mu r square. That is the reduced mass concept. I am using the reduced mass concept of central force. So mvr is the angular momentum. So here v is r omega. So r d theta by dt. So m v r means m r into r omega, that is m r square omega, that is m r square d theta by dt. Here I am using the reduced mass mu because I am using the concept of reduced mass because the sun is heavy and the earth is smaller compared, and that reduced mass is of the two bodies is mu, and this can be written as, you can see here, L by 2 mu dt. This comes here, L by 2 mu dt is half r square d theta. So you can see here these two are equally the same from this equation. If you take the dt in this side and r square in this, mu r square come in this side, I mean mu come in the left side. So finally this is the same. And now why I am using this is because you can easily convert this to area. Okay, coming to the next slide, you can see here the planet is moving. As the planet is switched, this is the radius vector. This radius vector makes a sweep of the area. This triangle is the area, and you are going to find out the area of this triangle. Approximately see that the half into base into altitude is the area of the triangle. So half r is the base of this triangle, r d theta is the height of this triangle. So half base r into height is r d theta. That means half r square d theta is the area of this triangle. That means the small element of this triangle, once the planet moves through a small time dt, and that travels a distance to an angle d theta. So you can see that is coming to this slide. You can see here, as you can see in this figure, the ellipse, this is the ellipse, and the area of this ellipse is given by pi ab. That is a semi major axis, b is a semi minor axis, and this area of this ellipse has to be, because if I say in the right hand side represents area, so therefore left hand side will also be equal to area, but left hand side is nothing but L by 2 mu dt. But in one complete revolution, that means one complete ellipse, if the planet completes, it will become capital T. So in the left hand side, you can see the expression becomes L by 2 mu into capital T is the time period of the planet. That will be equal to the area of the ellipse, that is nothing but pi ab. But here small a is capital A by 2. That is the major axis divided by 2 is the semi minor axis, and b is a semi minor axis. So that means we can, from this concept we know that uh, the value of a and capital A and b are found from the previous videos, and putting this equation in the above equation, that is L by 2 mu into t, putting these values in this above equation, you will get t square is proportional to a cube. That means t square is the square of the time period, that is proportional to a cube. What is a? A is the length of the major axis. Small a is semi major axis, capital A is major axis. So major axis of what? The ellipse of the planet. That means the planet's orbit is the ellipse. So that means we have proved the third law also. The third law says the square of the time period of the planet is proportional to the a cube, or we can say r cube. So accurately speaking, if you put the actual values, you will get this value only, because m plus m will come, and that if I approximately speaking, this is the, you can compare this as a constant k, and if you don't take the approximation, this will be the value of this expression. So in this case, you can see the t square expression. You can see the planet's mass also contributing to the t square value. But if I am saying small m is very very small compared to capital M, I can neglect this small m, and when I compare to capital, because m is the mass of the sun, small m is the mass of the planet, it is very small. And then we started studying various planets, and to study the relation, finding the value of this constant k for various planets. And you can see that means they depend slightly on the planet's mass. For example, for Jupiter, that is the largest planet, the small m by capital M is only 1 by 1000, so that the Kepler's third law holds too good in accuracy for all the planets in the solar system. So that means every planet in the solar system is very much accurately obeying a Kepler's third law. And also you can apply the satellites, this law can be applied to the satellites also. So we have a table, and you can see in this table various satellites are being used to understand the, you can apply the Kepler's third law to these satellites motion, which are various artificial satellites. We have only one natural satellite is moon, and you can see the various satellites from various countries: Cosmos, Explorer, Molina, ATS. These are the various satellites by different countries like USA, and from for these the eccentricity value, major axis value, time period, the k value, you can see almost the value of k is constant for all the satellites, which means the satellites also obey Kepler's law to good accuracy. So this come to the conclusion of this Kepler's law, and we come to the end of this video. Thank you one and all. Thank you.